In this sum, we have to solve z cubed plus 4 square root of 2 plus I 4 square root of 2 equals to 0. And this time we have to express the answer in a particular format. So let's begin. As you know, the first step is z cubed equals to minus 4 square root of 2 minus I 4 square root of 2. So we have to find z. That means we have to write z as this expression to the power 1 by 3. But before we do that, we have to express this complex number minus 4 square root of 2 minus I 4 square root of 2 as modulus argument form. So let's do that first. As we know, if a complex number is x plus iy, the modulus of that complex number is going to be square root of x squared plus y squared, and the argument is going to be y by x. But I always recommend that you draw the argand diagram before figuring out what the argument is. So what we have to do, first of all, let's find the modulus r. So square root of minus 4 square root of 2 whole squared plus minus 4 square root of 2 whole squared. So this is going to be 4 square is 16, square root of 2 whole square is 2, 16 2s are 32, plus this is also going to be 32 since they're the same. Square root of 64 is going to be 8. Now for the argument, let's draw the complex number in the argand diagram. This is the real axis and this is the imaginary axis. So the x coordinate is here, minus 4 square root of 2, and the y coordinate is over here, minus 4 square root of 2, and the point is going to be over here. So this is the complex number in this direction. So remember, the argument is either from 0 to pi or 0 to minus pi. So this is the argument. So our angle is going to be this one. So this is going to be our argument. It's going to be negative. But first of all, let's find the angle. So we can write tan of this angle is opposite by adjacent. So I'm going to use it using geometry of this triangle, no negative signs. So the opposite is 4 square root of 2 and the adjacent is also 4 square root of 2, which cancels off and becomes 1. So therefore this angle is going to be tan inverse of 1, which is pi by 4. That means the argument is going to be, argument of the complex number is going to be pi by 4, pi minus pi by 4. So pi minus pi by 4, and since it's in the opposite direction, it's going to be negative. So this is going to be 3 pi by 4. Minus 3 pi by 4 is the argument. Remember, the argument can either be 0 to pi or 0 to minus pi. So since we have expressed it in the modulus argument format, we can write z cubed is equals to 8 cos minus 3 pi by 4 plus I sine minus 3 pi by 4, and that's it. The next step is to write z and send this 3 to the other side as 1 by 3, but we have to write down the arbitrary angle, the complete revolution. So this is going to be cos minus 3 pi by 4 plus 2 pi k plus I sine minus 3 pi by 4 plus 2 pi k, and the whole thing would have a power of 1 by 3. So it turns out to be 8 to the power 1 by 3, and this is going to be cos. So since by de Moivre's theorem we can write this as n. Remember, de Moivre's theorem is if you have cos theta plus I sine theta to the power n, by de Moivre's theorem you can write cos n theta plus I sine n theta. That's de Moivre's theorem. So we can use that over here. So we can write this is n. So 1 by 3 minus 3 pi by 4 plus 2 pi k plus I sine 1 by 3 minus 3 pi by 4 plus 2 pi k. So this is going to be 8 to the power 1 by 3 is 2 because 2 cubed into 1 by 3 is 1, so 2. And this is going to be cos 1 by 3 into 3 pi by 4 is minus pi by 4 plus this is going to be 2 by 3 pi k plus I sine it is going to be the same minus pi by 4 plus 2 by 3 pi k. The next step would be to take the values of k and see how many revolutions we have to go through the arbitrary angle to get the argument between 0 to pi or 0 to minus pi. So for k equals to 0, so if we take k equals to 0, then z equals to 2. So if we put over here k equal to 0, it is minus pi by 4. So since the coefficient is less than 1, meaning minus 1 by 4, so this is going to be cos minus pi by 4 plus I sine minus pi by 4, and that's it. Now one more thing, since they have asked us to write down the answer in the exponential Euler's relation, so we have to write this as, if you remember, this is the rule. If you have cos theta plus I sine theta, it can be written as e to the power I theta. So that's the Euler's relation. So we can write as 2 is 2. So this would be e to the power I minus pi by 4. This is the form we have to express the answer in. Next, for k equals to 1, let's see whether it goes or not. If we put here k equals to 1, it becomes minus pi by 4 plus 2 by 3 pi. So let's use the calculator. So minus 1 by 4, we don't have to write the pi, and plus 2 by 3, 2 by 3, and this turns out to be 5 by 12. So it would be z equals to 2 cos 5 pi by 12. So it's also the coefficient is less than 1, so this is going to work, plus I sine 5 pi by 12. So the exponential form is going to be 2 e to the power I 5 pi by 12. Next, let's try if k equals to 2 works. It probably won't work because if you put k equals to 2, it turns out to be 4 by 3. And 4 by 3 minus 1 by 4 is obviously more than 1. Let's try. So this would be 4 by 3 minus 1 by 4, and this is going to be 13 by 12. Now 13 by 12 is more than 1, so it's not going to work. Let's move on to k equals to minus 1. So for k equals to minus 1, z equals to, let's check whether this works or not. It might not work. So it would be minus 2 by 3 pi. So minus 1 by 4 minus 2 by 3 is minus 11 by 12. It works. So it's going to be 2 cos minus 11 pi by 12 plus I sine minus 11 pi by 12, and that's it. And the exponential form is going to be e to the power I minus 11 pi by 12. If we take k equals to minus 2, it's definitely not going to work. Minus 1 by 4 minus 4 by 3, it's not going to work. So these three are the roots. Now one more thing about the form of the answer. They might have just asked us to leave the answer as it is. For example, 2 cos minus pi by 4 plus I sine minus pi by 4. Or they could have asked us to write down the answer in the format of x plus iy. In that case, you take your calculator and find the value of cos minus pi by 4 and sine minus pi by 4 and put the value. For instance, in this case, the value is going to be cos minus pi by 4 is, so cos minus pi by 4 is minus 45 degree in the degree mode. So it is going to be 1 by root 2. So this is going to be z equals to 2 just use your calculator and this is what you'll find. You'll find 1 by root 2 or minus I 1 by root 2, because sine minus pi by 4 is going to be, let's check, sine is in the fourth quadrant, so sine minus 45 is negative, so 0.707 is 1 by root 2, so that's what you're going to get. So the format doesn't really matter that much. You just take the answer and simplify it.